Hello and welcome to the On-Premise IT podcast, the only podcast that dares to be both on topic and on location. My name is Tom Hollingsworth and I am a part of Gestalt IT. Each episode we bring you the perspectives and viewpoints of a group of IT luminaries, experts in their field on a variety of enterprise IT topics. Before we jump into the premise or subject of today's episode, I'd like to introduce our guests.
Yeah, my name is Dominik. I'm at Network Autobahn dealing with encrypted and unencrypted traffic on the Network Autobahn for many years.
Hi, and I'm Jasper at Package on Twitter, and I'm the head of incident response at GData Advanced Analytics, and I used to look at network traffic, but now I don't have the time.
All right, thank you very much for joining us today. Let's jump into the premise for this episode. Traffic has become very difficult to detect anymore, and through no fault of our own. In fact, it's become very difficult because we're trying to make things better for everyone. You may have noticed that as you start going to websites, you no longer type in HTTP, you type in HTTPS. And even if you type in the former, it becomes the latter. We have started creating secure connections to just about everything. And that's great if you want to protect your information. It's not so great if you're trying to figure out what people are doing. So much traffic now is being encrypted by TLS that it's almost impossible to determine what's going on. And yet somehow we're able to do that through a variety of mechanisms that can generally be described as encrypted traffic analysis. And so we hear a lot about it in the industry, and I have to ask the question, is encrypted traffic analysis really worth it? Now, in order to kind of break this down, there's really two forms of this traffic analysis, if you want to call it that, and it kind of comes back to which version of TLS you're using. So prior to version 1.2 of TLS, we could do really fun things like decrypting the packets at a choke point, like a firewall, using a certificate. Does one of you want to explain exactly how we went about doing that?
Like the bad guys, just do it man in the middle. You know the certificate from your clients. You just have a short encryption from the client to your whatever choke point, and then the actually connection goes to whatever web server. I think that technology was kind of what we had back in the days. It comes with a lot of problems, but at the end of the day, if you don't look at the traffic, you don't know what it is. Yeah.
And to be clear, that required a lot of working in concert with other things, like your clients inside of your organization had to have a trusted association with a firewall certificate, and that way there were no warnings when the firewall decrypted the traffic and then re-encrypted it with a different certificate, sent it on, and then performed the option in reverse. Like if you were going to go to your, banking website or your healthcare provider. But it also created a lot of issues for organizations, even with those wonderful blanket policies of your data is not safe on this network or something like that. Still, I could run into problems where it's like, oh, you're decrypting all of my banking information at the firewall and you can see that somewhere in your logs. I don't like that very much. And so when we upgraded to TLS version 1.3, there were some provisions that were put in place specifically to end that particular problem that would notify a client when that certificate was being decrypted somewhere along the path. Has that stopped companies from wanting to do this, or have they found a way around it?
I think they still want to do it. I'm not sure if I don't know what the adoption rate of TLS 1.3 is. I think it's not that extremely high so far. I think we see mostly 1.2. But yeah, there will be a challenge, because basically what you need to have is like the secret of the endpoint, and the man-in-the-middle approach doesn't seem to work that well anymore. So there's, I think, companies who try to provide solutions by having agents on the endpoints picking up the secret keys to send them to the interception device or the decryption device. But I think we're a long way from actually wide adoption of that.
Yeah, and that only really applies to endpoint devices that I have full control over. And with the rise of things like BYOD, which I say rise, it feels like it was so long ago, but now with so many people running on effectively secure devices from companies like Apple or Samsung or whatever, it's almost impossible to intercept the session keys because I can't control that device. And so the providers of these solutions seem to have come up with a response which gives me a little bit of pause. So the new class of encrypted traffic analysis effectively does statistical calculations and heuristic analysis to determine what could be inside of a packet. And I've seen varying degrees of how this works from, oh yeah, we saw in this header that it was looking something like that with this protocol number, so obviously it must be Tor onion traffic, or it has to be some kind of a malware sample because all the devices that we've ever seen that communicated this way were infected with malware. But we don't know that for sure because it's scrambled through a TLS, certificate encryption. So does encrypted traffic analysis actually give us any better visibility into this than we already had, or is it just kind of a workaround for what happens when the clients don't let us play the men in the middle game?
I think it's kind of the only thing what you can do these days, yeah? So you have the problem, you would like to inspect, you would like to know what it is, yeah, but you cannot decrypt, so you have to use other methods. Is this 100% accurate? Maybe not. But maybe we can say on some things, we have a very high confidence that this looks like a certain type of traffic. We can identify that. We can have maybe learned this via machine learning or other mechanisms that we can identify what. Whenever we have a pattern that we can repeatedly see and then identify, we can also apply a policy to that. I'm with you. It's not accurate, and maybe users will run into problems because something is blocked that shouldn't be blocked. So it's of course not as good, but at the end of the day, I think we need to do at least something from a logging perspective, from an analytics perspective, instead of just, let's say, accepting the risk that people doing traffic that we cannot control to the outside. Yeah.
You have the problem right now that we too are from Germany, and Germany is, when it comes to privacy laws and data interception, it's really a critical country. So in most companies, you have a big fight ahead of you if you try to decrypt traffic. So doing the alternative of, well, not inspecting it at all, or looking at the heuristical approach, or even, I think what they're doing now is they look at a lot of the certificate headers. They try to figure out which kind of program is using them in which way. So I think a lot of the detections that they're trying to do comes from inspecting the certificates and the handshake and all the non-encrypted stuff. I think looking at the encrypted stuff or the packets itself, it's more like a packet size deviation and that kind of thing, so that you maybe can detect if this is like an interactive session with small packets. And it is something that you can do without having to deal with the whole, we are going to decrypt the traffic of everyone aspect, which can, in Germany, get you into a lot of discussion with a lot of parties involved.
And not only that, but one of the problems you run into when you're trying to decrypt all of the traffic is the size of the box that needs to have that kind of throughput is a lot bigger than you would normally want to use. And I mean, that honestly is one of the reasons why we've seen the rise of a lot of these services being placed in the cloud through things like SASE or SSE, is that I can terminate that traffic, say at a CASB or something like that, do some analysis on it, and then send it on its way. But you spoke about, kind of specializing in a specific kind of traffic. Let's just say, for example, we're looking for malware, because every trick that we've learned to do with protecting people's Facebook logins, malware writers have chosen to use that to obfuscate their payloads. My pause here is, of course, that if I can reliably identify certain kinds of traffic, and I say, well, I'm doing this for the greater good, I'm going to do this to prevent infectious crimeware in my system, there's absolutely nothing stopping me from saying, well, now that I know that I can identify specific kinds of traffic, what if I'm looking for people trying to get on Facebook at work and I want to block that?
Now, maybe you don't have to look at the encryption layer because you see the destination, so that is solvable in a different fashion. But I make a different example, which is DNS. Yeah. So a lot of companies, we're here at Cisco Live, for example, Umbrella, OpenDNS, or there are many competitors doing the same. They are also checking what kind of DNS request you make, you can then have kind of block list, known attackers or all the Tor node destinations and block these, yeah, so that your users cannot get a name resolution even for these sites. The problem that I see that HTTPS is becoming the new transport. People putting protocols like DNS on that, and then the traffic is encrypted, so you can no longer have these intelligent filters, and then it gets through. So one of the things that I see now is pretty common, just to block a couple of these DNS encrypted destinations. So the fallback is then unencrypted, and then you can apply something. That is one method. It's also not nice. We'll also run into problems, but yeah. And on the other end, the privacy thing, it's good that we encrypt, but on the other hand, if you sometimes people saying, oh, it's better if it is encrypted, yeah. But for example, let's go back for the DNS. You don't know if the DNS server that your application chooses to use for that is trustworthy or not, yeah? And the user often didn't even realize that he is no longer using the corporate trusted DNS server and is somewhere in the cloud, yeah?
Yeah, I think if you're looking at encrypted traffic and try to decide if it's malware or not, there's some criteria that will tell you with a high confidence that this is probably malware traffic. For example, we see this all the time that if the bad guys are building encrypted tunnels, they will do something that looks a little bit like HTTPS. It runs on the HTTPS port of 443. But if you take a look at the handshake, you will see that the typical client hello, server hello exchange in the packets just isn't there. It's a shortened version of that. So this looks like nothing a web browser would do today. So if you see this kind of thing, then you have a very high confidence that this is not the regular user HTTPS traffic to a normal website, but something that behaves, yeah, kind of not normal. And you could block that. So the question is, how certain are you that this kind of communication is a bad communication or not? And it's kind of possible, but there's always like a false positive that you can run into.
Or false negative.
Yeah.
Or false negative.
And we are back at statistics. So the bad guys, like you're saying, then often registering more domains. When one domain is not working, they're switching to the next one. Of course, we can then, as a defender, see, okay, there's traffic that is hopping to a certain thing. Sometimes you have a pattern on this new created domain. So you have multiple indicators. It's an fresh created domain. It is maybe following a pattern in the naming convention or anything that you can predict. And then even that it is encrypted traffic, you have some predictive measurements that you can apply and say, on this, let's say, value, we are 80% sure that this looks malicious, yeah? The other way around, this is one tweak what we can do. The other tweak is kind of the Caspi approach, yeah? I cannot decrypt the traffic to Office 365 because it will not work. They have all sorts of measurement to certificate pinging and so on. That is not making that possible. But what I can do, I can ask the API of Azure and Microsoft Graph API and give me back what this traffic looks like. So I get the information, even that I couldn't decrypt the traffic, but on the other hand, via API, I get the information. I add it to this whole communication string with analytics, and then I can understand, is this just a normal upload, or was this file maybe something with malware or something like that?
Or worse yet, was this a Word document that someone was uploading, or some other kind of document that maybe has confidential information that someone's trying to exfiltrate out of the system? And I think that that kind of goes back to what we're talking about here is your model's only as good as the data that you feed it. And we can observe things over and over again, but if we don't know what that is, we can never really say for certain. Whereas what you're saying is with, trusted providers, places that we know we want to work with, like Microsoft, that they can provide us analytics to help build a better model so that we can train what we're trying to do to say, well, we know this is traffic because it includes this extra metadata, and we don't want to block that. but we can also receive better, telemetry coming back going, yeah, they're uploading multi-gig files that are in a format that we don't associate with Microsoft Office or, knowledge worker work, and we need to do something about that. So is the future still going to be reliant on encrypted traffic analytics, or are we going to have some kind of a breakthrough that uses additional data to provide something akin to maybe like an AI or ML model that says I can associate with a high degree of confidence from things that I've seen that this is a malware communication string and you need to terminate it?
It's maybe a combination of both, like doing the encrypted analysis as they do now, and increase the confidentiality they have in the verdict that they do by using machine learning and all these big data approaches that they can grab so many samples that their verdict is more accurate than just looking at a small pool of like maybe a company or something. But if you look at all of it, all the telemetry that you could gather, that could lead to this being actually useful. And as an analyst, I think it's always the problem of if I have something telling me that there's something fishy is going on, if this is with a high confidence that it's something that you should take a look at, that is something where I can start. And then you can dismiss it if it isn't, but no visibility is not an option. So you need to have something that you need to start looking at and then sort it out. But the big problem and the challenge for the vendors will be the false positive rate needs to be as low as possible, of course, because otherwise you run into all the problems like alert fatigue and these kind of things. But if they manage to do that by using machine learning and all of this to a manageable level, I think then it's useful.
Yeah, I would say unfortunately the cat and mouse game will continue. The defending tools have now problem with the visibility. Yes, there are possibilities like API integrations, there are analytics, ML, there are possibilities, and I think also defending tools will get better over time, even with all this encrypted traffic. Then maybe the offensive side will find a way around it. So unfortunately, I see that not that this will ever stop at one point and we say we have solved it out. It will continue to evolve, and maybe there is also a phase where we go back to non-encrypted, who knows, yeah?
Yeah, and I think that ultimately that's the challenge that we face, is that for every advance that we make in security, it ultimately ends up protecting things that we really wish we could see from our prying eyes. And someone's always going to develop a better mousetrap and tell us that this is the solution to all of our mouse problems. But we have to examine why we're deploying them in the first place. Are we doing it because we're trying to protect our users, or is it because we're trying to control user behavior in a way that we wish they would do? I promise you that the first answer is going to get you a lot further with your users than the second. So as you look at what encrypted traffic analytics can provide, ask yourself, are you doing this for the greater good, or because you just want to make certain parts of your job easier? That should just about do it for this episode of the On-Premise IT Podcast. I want to thank our guests for joining us. Remember, you can always find the latest episode on our website at gestaltit.com/podcast. We should have a new episode about every 2 weeks. If you would prefer to listen to this in your favorite podcast application of choice, just look for the Gestalt IT On-Premise IT Podcast. And remember that you should leave us a rating and a review, because that really does help people figure out all about the enterprise IT stuff that we do, and hopefully they'll subscribe as well. We'll be back with another great episode very soon. Thank you very much for tuning in, and we'll talk to you then.